Welcome back to the video series on integration and differential equations. Today we're going to take a look at second order partial derivatives. So before we do an example, let's make sense of the notation that we're going to be using. So let's start with delta squared z by delta x squared. What this means is apply delta by delta x to delta z by delta x. So in words, we'd say this is the partial derivative with respect to x So I'm going to write WRT when we say with respect to. So partial derivative with respect to x of the first partial derivative, which we would have already calculated. So delta z by delta x we would have already calculated, and we're now taking the partial derivative with respect to x of that previous partial derivative. So this is an example of a second order partial derivative. Okay, one more piece of notation here. Let's say we look at delta squared z delta y delta x. So what this means is apply delta by delta y to delta z by delta x. So we would have already calculated this delta z by delta x, and now we're going to apply the partial derivative with respect to y to that. So if you say this in words, it's the partial derivative with respect to y of delta z by delta x. All right, the notation for partial derivatives is a little bit different than what we've seen before, so it can be helpful to go over the notation in advance. Many people might just prefer to jump into an example and to learn the notation by example. So let's try that. So here's our example. Z is equal to x cubed y to the fifth. That would be an example of a surface in 3D. And we're going to find all second order partial derivatives. And we'll see that there are actually 4 second order partial derivatives that we should calculate. So let's start with the first partial derivatives, the first order ones. So if you watched the previous video on first order partial derivatives, you should hopefully remember that to calculate delta z by delta x, we're going to be treating y as a constant. So this derivative, this partial derivative would look like 3x squared times y to the fifth. And if we do the same thing, I'm going to leave some space here. Let's calculate delta z by delta y over here. If we do the same thing with respect to y, this time we have to hold x constant. So we're going to treat that number x cubed, or we're going to treat x cubed just like a number. So we'll keep that out in front, take the derivative with respect to y, and we'd have 5y to the fourth. So overall, we would write that 5x cubed y to the fourth. All right, so that's our first order partial derivatives done, and we can move on to the second order partials. Let's start with delta squared z by delta x squared. So first step is just to understand the notation. We're going to apply the operation delta by delta x to the quantity delta z by delta x. Okay, and we calculated delta z by delta x in the previous step. We know it's 3x squared y to the fifth. Okay, so now it comes down to taking the partial derivative with respect to x of this quantity here. So that's going to give us 6x y to the fifth. So that is our very first second order partial derivative done. 3 more to go. So let's try delta squared z by delta y delta x. So first, understand the notation. we're going to apply the operation delta by delta y to delta z by delta x. Looking back to our previous step, we're just going to replace this delta z by delta x with 3x squared y to the fifth. Okay, and this time the operation that we're doing, taking the partial derivative with respect to y. So we're going to be treating x as a constant, meaning this 3x squared there, that's just acting like our coefficient, and we're taking the derivative of the y to the fifth to give us 5y to the fourth. So overall, 15x squared y to the fourth is what we're getting for our second order partial derivative. Perfect. So that's 2 of the second order partials done. In both of these cases, we started with taking the first partial derivative with respect to x, and then from there we could differentiate with respect to x or with respect to y. So now we're going to start at the other situation where we do the first partial with respect to y, and then we can do the second partial with respect to either x or y. So let's try delta squared z by delta x delta y. So first step, notation. We're going to apply the operation delta by delta x to delta z by delta y. Okay, and looking back at our previous step, delta z by delta y was 5x cubed y to the fourth. The operation that we're going to do here, we're going to differentiate with respect to x, so y is just being treated as a constant here. Taking our partial, we're getting 15x squared times y to the fourth. No simplification required there. So that one's done. And then let's go on to our very last option. The last thing that could happen is we could have delta squared z by delta y squared. So in terms of notation, that means apply the operation delta by delta y to the expression delta z by delta y. Alright, so plugging in here, we know delta z by delta y is 5x cubed y to the fourth. And we're going to be differentiating with respect to y. So x is being treated as a constant here. That 5x cubed will just stay in front as a coefficient, and then we differentiate the y to the fourth to get 4y cubed. So overall, 20x cubed y cubed would be our answer there. So there we have our 4 second order partial derivatives. So in looking at these 4 second order partial derivatives, you may have noticed that the middle two came out equal, and you might be asking yourself whether that's just a fluke. Turns out it's not a fluke. So here's a general fact. So these 2 second order partials that we're looking at, they're called mixed partials or mixed second order partials because we're differentiating first with respect to x and then y, or the other way around, first y and then x. And so it turns out that the mixed partials are equal for most surfaces z. I'm not going to get into the details of what conditions make that true, but let's just say for most surfaces that you're likely to run into, these mixed partials will be equal. So that can be a handy fact to use just to double check your work, just as a partial double check towards your work. Thanks for watching, and we'll see you in the next video.